Okay, so we have another equation, and it is similar in nature to this equation that you solved last time you were here, right? And what was the key to solving this equation that had the factors or the fractions? You had to get a common denominator. So what's going to be the key to solving this equation? A common denominator. So we're going to have to get creative here and figure out a common denominator. So just looking at the denominators, you have a 5x, you have an x squared, which what is an x squared? An x and another x being multiplied, right? And then you have another x squared. So what does the common denominator have to have so that everything is included? It's got to have an x squared, right? If it has an x squared, then this one's good and this one's good, and then we could make that into an x squared, couldn't we? X squared, they all have to have x squared in them. What else do they all have to have? A 5, right? Because this first one has a 5, so as long as these also have a 5, so our common denominator will be 5x squared. So we're going to multiply each fraction, each denominator, by what we need to get to 5x squared, all right? So if you have 5x, what do you need to multiply to get to 5x squared? So this one's going to be times by x on the bottom and times by x on the top. Say it again. Instead of what? Instead of what? Yeah, you can just put x instead of 1x. That's fine. This second one here, what does it need? 5. It needs a 5, so we're going to times the bottom by 5, and we have to times the top. And since the top has 2 pieces, you have to times both pieces. So put parentheses around it because we're going to have to distribute there. And then what does the last piece mean? 5. So that's going to be multiplied by 5, and the top also multiplied by 5. And now every single one of our denominators will be a 5x squared, won't it? And once all the denominators are the same, what can we do with all the denominators? They will cancel them all out because you're dividing by the exact same thing. So see you later, denominators. And you're left with what's in the numerator. So 1 times x is just x. It's going to equal 5, and then that'll be times x minus 6. So we're going to distribute 5x minus 30. And then this is a subtraction, right? So minus 1 times 5, which is 5. Can you all solve this equation? All right, go for it. I'll work it on the board. You work it on your paper. For this one, it doesn't matter, but if it doesn't matter for this one because it's a 0.75 decimal. If it was going to be like a 0.3876 crazy decimal that you'd have to round, you should stay in fraction. So fractions are more exact unless the fraction simplifies to a really nice like 0.5 or 0.25 decimal, or like just a 0.2 decimal. So if it's a really nice decimal, go for it. But for the most part, sticking with fractions is not a bad move. It's 8.75, right? Yeah, 8.75. So what do you think? Super crazy? Do you see what we did with the work problems, how that really helped us out with what we're doing today? All right, one last thing, though, that you didn't have to worry about with the work problems that you do have to worry about here is that there's something in math you have to be careful of because you're not allowed to do this with a rational function. There's an issue, and the very first thing we talked about when we talked about a rational function is you can't do what with it? No, not imaginary. That was the issue we talked about with quadratics. That's another issue in math, but the other one with rational functions, you can't. Huh?
I don't know.
Oh. Oh, yes. Where do extraneous things come from? Not only imaginary, but we are looking for extraneous solutions. We have to check to make sure it's not extraneous. Because where would we have problems with a fraction?
It will be like you know what I mean? Like if one thing to the top, you bottom.
No, you all are way overthinking this. What can you not do that has a fraction? The fraction is what operation? You can't divide. You can't divide by zero. There you go. You cannot divide by zero. So in math, there's two rules that you know so far. You can't take the square root of a negative number. That's where imaginaries come from, right?
But you can.
But you can as long as you go into the imaginary number system. But one of the other rules of math is you cannot divide by zero. So what we have to check is we have to check to make sure that this number does not make a denominator equal to zero. You don't have to check the entire equation, just the denominators. So if you put 35 over 4 into 5x, is that going to make a zero? No. If you put it into x squared, if you put 35 over 4 in squared, is that going to make zero? That's the same thing, so it will also not make zero. So that means that this is the solution. So it is checked. You're just checking to see if it causes a divide by zero issue. All right, let's try another. We have 4 denominators, and 2n squared, 3n squared, and 3n squared. So we need a common denominator. What should we go with for a common denominator? 6n squared. What do y'all think? Yes? 6n squared?
Yes.
Yes? So we're good? 6n squared? They all have n squared, so that turned out really nice. And then you have to make all the coefficients 6. So this 2 right here, how does it go to a 6?
3.
Times it by 3 in both the top and the bottom. How does the 3n squared go to a 6n squared? 2 on the top and the bottom. 3n squared again, how does that go to 6? We also have to multiply that one by 2. And now that all the denominators will be the same, what can we do with them? They all are going to simplify. All right, so the top, make sure you distribute whenever you had 2 terms in the top. So it's 3n minus 3 equals 2. 1 times 2 is 2, plus 2n minus 10. All right, go ahead and solve on your own. I know you can finish this. Solve away. Yeah.
Are we allowed to look back?
Oh, no, you can't be ahead. I don't answer ahead questions. Only correct questions, because then people get confused. All right, -5, what'd you think? -5? -5, -5? Did you check it yet?
Yes.
Make sure you check it. If you put it into a 2n squared, will it make it 0?
No.
By the way, what number makes that 0? 0. So unless it's 0, you're okay here. 3n squared, that's not going to be a 0 either, right? The only thing that makes that 0 is 0, and the same thing there. The only thing that makes it 0 is 0. So if your answer was 0 at the end, it would be extraneous. It wouldn't actually work. So any other number is fine. So -5 is fine.
So if it does not 0,
If it makes one of your denominators equal to 0, cross it off and just say it's extraneous. And if it was the only solution, the only number that you had, then there would be no solution. All right. Jumping down here, number 3. This got a little bit more complicated. Why is this one slightly more complicated than the two we just did? There's two pieces, two terms, right? Is that what you're talking about? So each of the denominators have a plus or a minus in them. You have something being added or subtracted. Now, I will tell you, sometimes we get this idea of like, oh, I can just add to a denominator and add to a numerator. You may only multiply, okay? Your only option is to multiply the top and the bottom. So what should we do? Any thoughts of how we might approach this? Can we multiply this term by b? What do you think? Yes, no? I don't see why not. What if we multiply that middle term by b? What are we going to get? B squared minus 2b. And that's what we have for the other two. So before we do that, though, what is the common denominator?
B squared minus 2b.
It is b squared minus 2b. But instead of thinking about it in terms of individual numbers, because this one was easy to see, you could have factored this. How does it factor? B, right, times b minus 2. So this is a b and a b minus 2. This is a b and a b minus 2. This is just the b minus 2. So what does it also need? It also needs the b, all right? So you are going to do some factoring here. All right, so just that middle term here needed to be multiplied by b on the bottom and b on the top. Everything else, now we have common denominators, don't we? All right, so what does that mean about our denominators? They're going to cancel each other out. You're going to have 1 plus b equals 4. That's a tough equation, yes?
No, I don't think that's also right yet.
B equals 3. 1 plus b times 1 is just b equals 4. So b equals 3. And then what do you have to do to make sure that that's okay? Make sure it's not extraneous. Make sure it doesn't make a denominator equal to 0. And so you can go based off of your factors here. The common denominator was b and b minus 2. Will it make either of these equal to 0? No. What are the two numbers that do make this equal to 0? 0 and 2. 0 and 2. And so you cannot have 0 or 2 for an answer, but you can have 3. 3 is okay. So check that one works. All right. Moving on, number 4. I think I made it harder, didn't I? Maybe a little bit?
What?
Not yet? What do you think here?
Just wait.
Those just cancel each other out.
No. Not so fast. Not so fast. What's the rule for denominators to cancel each other out? Every single term has to have the denominator, right? Now the problem here is this 1. Jeremy, you paying attention?
Yeah.
You don't mess this up. Because you're going to do what Shanna said and get rid of them and you're good to go, and that it won't work. So you may only get rid of denominators if every single term has that denominator. Every single term. This one has b minus 2. This one has b minus 2, but look at that guy right there. Does he have b minus 2 in the denominator? No, so you can't get rid of the b minus 2s unless every single thing has the same denominator. So what do you want to do? I don't know. I heard like 8 people at the same time. Anybody want to raise hands on this one? Shannon, what do you want to do? Make his denominator b minus 2, because then what can we do? We can get rid of all of them. So what we're going to do is we're going to say, all right, Mr. 1, you got going on here. You need a denominator of b minus 2. And if you put it in the denominator, you have to put it in the numerator. So the top also gets multiplied by b minus 2. So the number 1 turns into b minus 2 over b minus 2, which is equivalent to 1, right? As long as you have on the same as the top as the bottom, then it's equal to 1. And now that all the denominators are b minus 2, now what may you do? Now you can get rid of them, right? So we have 5b equals 1 times b minus 2. If you distribute the 1, it's just b minus 2, right? And then that's a plus 5. Plus 5. Solve away.
Actually did that right. Fast.
Did y'all come up with the 3/4? 0.75, 3/4? All right. Does it work? Is it a solution or is it extraneous? Because you got to check.
It works.
It works. What number does not work? If we had gotten what number? 2. If we had gotten 2, that would have been bad news, right? Any number besides 2 is good, and check, yes, it works. How are we feeling so far? Mm-hmm.
Great.
Jeremy, why
Great.
you can be happy for it.
Oh yeah, no, I'm happy. I forgot about that.
All right. Number 5. This looks like it got easier now, doesn't it? Oh, it's a lie. Well, we need a common denominator still, yeah?
2x to the second.
Common denominator. I hear 2x to the second. Do you agree with her or no?
Yes.
Wholeheartedly agree?
Yes.
Yes.
This has the x squared, so we'll be good there. We can make that x squared. Yeah. I'm cool with this. So what does this first one need? A 2. So 2 on the top, 2 on the bottom. What does the middle one need? An x on the top, x on the bottom. What does the last one need? An x, and it has to go, since there's 2 things on the top, you're going to have to distribute, right? Right? Distribute. All right, and now all the denominators will end up being the same, so what can we do with them all? All right. When I want work on this problem, I'm looking for this. This right here. This is work, okay? So that's what I'm looking for. What you got going on there? 2. There's a minus there, so minus 5 times x, so minus 5x equals x squared minus 6x. Distributing the x brings out an x squared. All right, y'all. How do we solve it?
Can we move the 2 over?
You can move the 2 over, yeah.
No, like the 2 and the negative 5.
Yeah, you can move both the terms over, set it equal to 0. I'm good with that. So it would be x squared minus x minus 2.
When did you plus 2? No, wait, no.
I didn't think
I did.
And then you factor it.
And then, hey guys, what do we do now? We
Factor.
factor. What if it can't factor?
Wow.
Quadratic formula. What if we wanted to be really crazy and do something different? You could complete the square, right? It does factor, I believe.
It does.
2 numbers that multiply to be negative 2 add up to be negative 1. Negative 2 and 1, so x minus 2, x plus 1. So x equals 2 and negative 1. So this equation doesn't have one answer, it actually has 2. Both of those numbers make this equation true, unless one of them is extraneous. So let's check real fast. It might be useful to just say, hey, what number can we not have?
0.
You can't have 0, right? X squared, can't put in 0. 2x, can't put in 0. 2x again, can't put in 0. So as long as you don't have 0, then your solutions are good. So there are 2 there, 2 and negative 1. All right. You want to try one on your own? You want to give number 6 a shot? All right. Let's have you give number 6 a shot. See what you come up with for number 6. And don't worry, I will come back and help you with some of these other ones. So give 6 a shot. See what you come up with.
Yes, no.
Mine was hard because I didn't know what so I did that. I was trying to square the b with it. And I also did the wrong sign, so I did plus 5x instead of minus 5x because I didn't do that.
Do it.
The details will make difference, won't they?
I What are you doing?
Which one are we doing?
Number 6.
Is that a divider plus what?
Plus.
Uh-oh.
What?
I said yours that they're smiling.
You can't really tell. I have a mask on. Am I smiling? Am I smirking? You do like learn to read people's like emotions in their eyes a little bit better.
Yeah,
Mm-hmm.
I forgot who half of y'all look like that.
So I'm like, your eyes are telling me you're not doing so good.
I'm so smart.
All right. So this first one, they both need a B, don't they? Yes. The second one, they both need a B as well, right? And then that last one is already 2 B's. So we just made them all 2 B's. Is everybody okay? All right. So you can get rid of all the denominators now that they're all the same and take care of your numerators. So we'll distribute B squared plus 5B plus 1 more B equals, and then nothing changed over here because I already had the right denominator. And so you ended up with this equation. So what'd you do to solve? You put all the stuff on the left onto the right? All of it? You don't technically have to put all of it. You can, but you don't have to. One thing that I noticed is the B squareds. What's going to happen with them?
They cancel out.
Yeah, if you subtract B squared and subtract B squared, both of them are now gone, aren't they? So really, if you think about, I'm going to put those together actually. 6B equals 10B plus 24. You're now looking at that equation to solve. So it did have a quadratic, but it was really fortunate for us because we didn't have to factor anything like that because quadratics simplified themselves out. So minus 10B would be negative 4B over here, equal to 24, and I have B equals negative 6. Is that going to work in my equation?
Yes.
Yes, because the only thing B can't be is 0 again. It can't be 0. You could have solved from here and done some different stuff. As long as you got negative 6, you're okay. All right, there's lots of ways you could have approached that equation. So the steps from here to here, you could have done like 18 different things. If you get negative 6 at the end, your way works. If you didn't, your way didn't work. You made a mistake. How did that go? Did that go all right? Yeah? All right. We have 2 more we're going to do together. All right, take a look at this next one. There's a lot more going on here, isn't there? Just more stuff in general. All right, I have a k plus 4 for a denominator. I have a 3k squared plus 12k, and I have a 3k plus 12. For the common denominator, if you can't tell, what should we do with all the denominators instead? if you can't tell, like it's not jumping out to me what the greatest common denominator is here. I think there's a 3. I would assume there's a 3. But if it's maybe not as obvious, what should you do with all the denominators? Well, we want them to be written as multiplication. So how do you take something that looks like this and put it into multiplication? How do you take something that looks like this and put parentheses, multiplication? What's that called?
Distribute.
No, you do the opposite of distributing. Factoring. Yes, factor. Factor each one of the denominators, all right? And we'll see what we have, and then we'll see what we still need, okay? Does k plus 4 factor? No. All right, so that one's done. Does 3k squared plus 3k factor?
Plus 12K.
What?
Plus 12K.
That's okay, that's 12k.
Yes, 3 sure.
3k comes out. There's a GCF, right? K plus 4. Is everyone okay on the factors there? So cross off this one, and instead of using that more complicated version, we're going to go with the factored form. And this last one, does it factor? Take out a 3, and left over is k plus 4. And get rid of this guy, the more complicated one. We're going to stick with the factors. Is it easier now to see what things have and what they don't have?
Can you technically just multiply the others to get 3K squared plus 12K?
Yeah.
You could, but it's going to be a lot easier when things get more complicated to just go ahead and factor and see what they have and what they don't have. So, for example, they all have a k plus 4, don't they? So k plus 4 is part of our common denominator, but every single thing already has it, so we're good there. This one has a 3k, and that one has a 3, so we're going to need all of them to have a 3k. So that first one right here, what does it get multiplied by? The 3 and the k, so that it's going to match this. The top also gets multiplied by 3k. So now these two match, right? Those two match. What does this last one need in order to match the other two?
Okay.
A k, because it has a 3, but it's missing the k. So we're going to times this one by k, and the top of this one also gets multiplied by k. So if you're not sure what the common factor is, because there's some pluses or minuses in the denominator, you should factor. It's going to make it a lot more obvious what the pieces are and what you're missing.
Okay.
There's a lot of k's, yes. All the denominators are now going to be the same, right? They're all going to be 3k and then k plus 4. So all the denominators will go away, and you'll just be left with your numerators. 3k times 4k is 12k squared. This one, there's nothing that happened here. There is a plus sign in front of it, so it's just going to be plus k squared minus 2k minus 3. So that didn't change at all. And then this last one, we're going to distribute the k. So k squared minus 2k. All right, what do you want to do now? Now we got to solve this equation.
Move this stuff from the left to right.
So move the stuff. I wouldn't necessarily go left to right. I would go right to left because of this 12, right? Keep it positive. It really won't matter as long as you still do the correct operations. So that'll be a minus k squared and a plus 2k. So here we're going to have 12k squared plus k squared minus k squared. So this will be 12, 13, back to 12, right? So that's a 12k squared. Here we'll have negative 2k plus 2k, so we won't have anything here, right? Minus 3 equals, and then this is 0 and that is 0, so equals 2, 0. So we have 12k squared minus 3 equals 0. Once we combine all our like terms. All right, how do we solve this guy? Move the 3 over, okay. Equals 3. From there, divide by 12, we can do that. So we'd have k squared equals 3 over 12, which 3 over 12 simplifies, right? 1/4, okay?
Don't you have to like square root to get?
And then now you can take the square root. So k equals, don't forget, whenever you take a square root, what do you include? Plus or minus. What's the square root of a fourth? What's the square root of 1? What's the square root of 4? So what's the square root of a fourth? 1/2. Plus or minus 1/2. So you have two solutions, 1/2 and negative 1/2. And this is what we call this square root property. And you could use it because those k's, the just single k's, right here, they simplified it. We didn't have any anymore. So square root property is always good after that. All right, and last but not least, you have to check both to make sure that they're okay in our equation. So go back to your denominators. Now that they're all the same, just check out one of them. What numbers make this denominator equal to 0? 0 and negative 4. So as long as you don't have 0 or negative 4, your answers are good. All right? Yes? Both of these work. So this has two solutions to this crazy equation. All right, do y'all have any questions about that? Really, from here on out, all of this, we technically did that first trimester, didn't we? That was all first trimester stuff. So this piece right here, getting common denominators, was kind of the only new thing there. But you did have to combine what you learned first trimester to help you. All right, last one. And apparently the scariest?
Yes.
Yes?
Yeah.
R minus 3, and then r squared minus r minus 6. And then the 1 doesn't have a denominator right now. So what do you want to do? Factor, yes. Whenever you're not sure what a common denominator is because you have these pluses, minuses going on, you should factor. So r minus 3 doesn't factor, right? But this one here will. Multiplies to be negative 6, adds up to be negative 1. Negative 3 and
That makes everything.
positive 2. So get rid of this denominator. You don't even want to look at it anymore for the rest of the problem. Just cross it off. And you should notice that, hey, that one already had the r minus 3, and there's an r minus 3 in this one as well, right? So r minus 3 is part of that common denominator. What does this one also need to match this one? An r plus 2. So on the top and the bottom, you multiply by r plus 2 and r plus 2. All right, are we ready to just get rid of all denominators?
That's way easier.
Multiply the R. You have to multiply the factors, the 1.
You have to do the 1 as well, right? You can only get rid of the denominators when every single term has the same denominator. And right now there's a term of 1 over here that does not have the r minus 3 and r plus 2. And so you need to change it so it has an r minus 3 and an r plus 2 in the bottom, which means in the top it also has to have a r minus 3 and r plus 2. Now all the terms have the same denominator, right? Okay. So all the denominators are going to go away. In this first part, you have r plus 2 times 1, which is just r plus 2. In this second factor here, you just have a 5, but it is a minus, negative 5, minus 5. And then on this side, you have r minus 3 and r plus 2, and you should go ahead and distribute for the solving purposes here. So it actually just goes back to what we already had there. Sorry. Hit random buttons. R squared minus r minus 6, you said?
Yes.
And then you have to solve. So I want to combine some like terms, yes?
See.
So I'm going to minus the r over here. These two make -3, so if I add 3, right, that'll get rid of both of those. Add 3. Kind of see what I did there? I put them together in my head, made -3, so I was like, all right, we got to add 3. So this side would be 0. R squared minus 2r minus 3. And last but not least, how do you figure out the solutions here? Factor. Or you could complete the square, or you could quadratic formula. Anybody remember how to complete the square? Kind of, sort of, a little bit.
They bring it out to the side, and then you do take it half, square it.
Yep.
and
Yeah.
like
If you had me, we talked about it in a slightly different context, but yes, that's exactly what you do. All right, we're going to factor, though, because it's factors, so that'll be a lot easier. So 2 numbers that multiply to be -3 add up to be -2. So solutions are r equals 3 and -1. And so there's 2 here, but we have to check to make sure that we don't have any extraneous, right? So what numbers make any of these denominators equal 0? What numbers can we not have? 3 and -2. And we have a 3, so we have to cross it off because, can't write anymore here, it is what we call extraneous. And I always remember extraneous because of the word extra. It's like an extra solution that happened in there. Extraneous. And so this only has one solution. Only -1 will work for this equation. All right, that is it for the notes for today. There are a few questions on the back. How many are on the back? 8 more? 8 more. So that will be your assignment for Monday. Your Monday, your off day assignment. You can start now.